you a couple of science experiments. So we're going to get started. Mr. Brenner, take it away.
All right, thanks, Ms. Ford. We're going to start with a chemical reaction. Now, before we start, it might be good to discuss what is a chemical reaction. Well, a chemical reaction occurs anytime we have two substances that combine together and a new substance is created. It's different from a physical change. If I have this paper here, if I tear it, it's still paper, right? The form or appearance might have changed, but not a chemical reaction. So let's try mixing some things together and see if we can come up with a chemical reaction. So we're going to start with hydrogen peroxide here. Now, if you don't know, hydrogen peroxide is used in first aid. It can be used for cuts and scrapes, things like that. So I'm going to put some into this container here. I'm just kind of estimating, not getting an exact amount. All right, I think that's good. And then next, got some shampoo here. We're going to put some of that in here as well.
In case you don't know what shampoo is for, that's for washing your hair.
Yes, that's an important one. And we got food coloring as well. So I'm just going to put some of those drops in here. All right, now let's mix it together. And some things we're looking for to see if it's a chemical reaction, we might notice that the color or temperature change unexpectedly though. Sometimes in physical changes, color or color especially might change. We might see a precipitate form, which a precipitate is like a solid forming inside. We might see bubbles, that's a sign like gas has been released. Or burning things, the fancy word for that is combustion. That is also a sign of a chemical change. So let's kind of mix it up here and see what we got. Now, what do we think?
There's some bubbles.
Bubbles. We put shampoo in though, right? So we probably expect bubbles when we're mixing up shampoo. We put food coloring in here, so we probably expect that to happen. So what if let's see what else we got here. We've got some potassium iodine. What if we take that and let's put it in and see what happens. Alright, let's mix it up a little bit. I can already see we got a weird color. Is that kind of brown, orange?
Brown.
Okay. And mix it up a little bit more. And let's see what's happening. It's kind of going a little bit slow, but oh, look at that. Here we go. It's starting to ooze out the top a little bit. We see some, that
bubble. It looks like it's
a big bubble. And look at that. It's starting to foam out the top. So do you think we have a chemical change here, Ms. Ford?
I think that's a chemical change. Look at this. It's starting to ooze out, like slimy pouring out.
Yeah, it's also kind of getting hot now to touch. So I think we've got a chemical change for sure.
Look at that.
These substances formed.
It keeps going.
That's going to be a mess to clean up, but that's all right.
It's a little gross, like I don't know what. But, Mr. Brenner, I think you did a chemical change for us.
I think so. All right. What do you have for us, Ms. Ford?
Well, I like to make things a little bit dramatic. If you know me, you know that. So I got something here called dry ice. Dry ice is frozen carbon dioxide, and it's very, very cold, so it is not safe to touch with your hands, which is why I have my handy dandy tongs here. So I'm going to carefully take a piece of dry ice, and I have another really exciting substance here. This substance is water. Maybe you've heard of it. So I'm going to take my dry ice, my frozen carbon dioxide, and put it into the water. Let's see what happens. There's some bubbles forming, and then there's all this smoke and fog coming out. So what happens is this dry ice is starting to turn into a gas. If you put normal ice in your water, it'll melt and it'll turn into a liquid. But this is carbon dioxide, so it doesn't turn into a liquid, it turns straight into a gas, which is why all these bubbles are coming up and all of this fog and smoke. It's really nice for a spooky entrance to put somewhere. The really important thing about dry ice, though, is you cannot eat it or drink it. So, Mr. Brenner, I know you're tempted, but don't take a drink of this water. It's very dangerous for you. So, we'll let this continue to fog up over here.
Chemical reaction's still going, as you can see.
It's just going to keep going. We've got lots of reactions here, lots of messes to clean up. But that's the best part of science, is science is messy.
Yeah. So now we've got a couple things for you guys to try in your classrooms with your teacher. So kind of in our the theme that we we have for National Lutheran School Week and our school year, Sent to Serve. You might be talking about in your classrooms how we have missionaries that go out in the world and travel to different places. We've got 2 things that you guys are going to create that involve traveling. We're going to first talk about paper airplanes. Everyone loves paper airplanes, right? So I've got some paper airplanes that I've already made here. And what you can do in your classroom with your classmates and teachers is test them out. Try to come up and see with who has the best design to make it fly the farthest. I've got 2 different ones here. There are many different ways to make paper airplanes. I got this one. It's got longer wings. This one's got more of a narrow body. And just test them out. The best thing you can do is test the distance. That one didn't go too far, so maybe that's not the best design. So challenge yourself. Who can come up with the best design? Who can throw it the farthest? And that's what you're going to test. You can also challenge yourself too. If you want to challenge, maybe see if you can throw it and try to hit a target. What you can do is you take some scissors on the ends of the wings. You can make what's called ailerons. And if you want to try to get it to turn, you can fold one up. And you could fold one down, and folding one up, folding one down. Now this is going to cause the wind, the air that's going against the wing to move down. This one's going to cause the wing to go up, and it should get it to turn. Yeah, kind of. Coming right into your classroom there. All right, so have fun with that one. Try to test out different designs. Maybe if your teacher will let you, you could research some different designs on the internet and see who can make a paper airplane that goes the farthest.
The other activity is a boat. Sometimes people travel by boat. So you're going to get some foil and you're going to get to fold it into a boat shape. And then you're going to get to put it into, your class will have a tin with water, and you're going to put your boat into the water. Your goal is to keep your boat from sinking. I don't know about you, but I think a boat is best when it stays above the water like it's intended. Some challenges for you is to create a boat that can hold the most weight. Because typically boats don't travel empty. They're either going to have people or cargo or something in it. So your challenge is to create a boat that when it's in the water, it stays afloat. And if your teacher wants, to have a boat that will stay afloat and hold the most weight. We hope you have a great time and enjoy your science day.
Have fun.
Have fun.